Hi, Michael here. Today's topic is focused on the practice of preparing a small-scale Azure environment that will allow us to run any cloud service cost efficiently with emphasis on cybersecurity. Before we begin, just a quick notice. The recording is divided into three parts: theoretical introduction, infrastructure creation, and the review of possible network configurations with a focus on cybersecurity. You can choose the part that interests you most. The business decided to create an infrastructure that will meet the basic requirements. Web application is served by Nginx as a reverse proxy. The application should be able to use MS SQL database. There should be possibility of using a microservices architecture. We need to implement basic network monitoring. We need to assume that we will add more microservices in the future. Based on the description in part 0, we assume that cybersecurity risk is low. The architecture does not focus too much on the aspect of application availability. The most important element for us is confidentiality and integrity. Also, we will need to limit the costs associated with the infrastructure as much as possible. The method of launching the application depends on the approach used. In this case, we can for example decide to use AKS due to planned microservices development. Because of the lack of requirements for web application availability, we can create a single node AKS cluster. So all we need is to take care of the security of the two Azure services, AKS and MS SQL. It's simple. A few clicks in the settings of the services and everything will be ready. But is that all? Well, not really. We also have virtual networks, network interfaces, disks. And also, while we are using AKS cluster, we will need something to publish our applications. So we will need something like Application Gateway or Azure Front Door. We also shouldn't forget that we need to store somewhere our secrets. So we will need something like Key Vault. And also we will need to store somewhere our container images. So we will need container registry. We also have Locanalytics Workspace, Defender for Cloud, Microsoft Entra, and Manage Identities. So there is a lot of stuff that we need to take care of. To secure some of these services, we could of course follow the Defender for Cloud recommendations. In our case, however, not every recommendation will be justified because of our cybersecurity risk, which is low. Due to cost-effective approach, we must decide to apply bare minimum in terms of security controls, unfortunately giving up some of the solutions provided by Microsoft. To meet clients' requirements, we don't necessarily have to choose a AKS solution at this point. Alternative solutions are virtual machines, app services, or container instances. We will start with the example most often chosen due to the possibilities it offers. One of the most important layers we should focus on is network layer. There can be many layers according to the defense in-depth methodology. In this material, we will focus on the basic network isolation of the infrastructure. We need to control the way our resources communicate inside our or external virtual network. However, we will not focus on how to create resources, but how to configure our resources to make our infrastructure more secure. So let's see briefly what our Terraform code looks like. Here we have our infrastructure code written in Terraform. I won't be digging into this code too much, just a quick overview. One thing here only to highlight. Storing Terraform state in a storage account is not the best practice. For storing Terraform state, I would opt for dedicated solution like Terraform Cloud or anything dedicated for that purpose. Now, let's have a quick look at the resource.tf file. Here we can see our resource group, virtual network, subnet, and dedicated module for our virtual machine. Next is our variable file, where I point to my tenant ID and subscription. The module for virtual machine is also very simple. It only consists of some must-have resources. Please keep in mind that I'm not focusing here on defining everything in the Terraform code. Most of the security-related changes we'll do inside Azure portal, and that is only for demonstration purposes. However, it is recommended that the most changes should be implemented using infrastructure as a code approach. So let's now apply our Terraform resources and modules. As you can see, everything is ready to be delivered. Let's now run our Terraform script and wait for results. After provisioning our infrastructure via Terraform, we can see our resources inside our resource group. Is our environment already secure? The question should be, is the cybersecurity risk associated with our environment acceptable to us? It all depends on the risk analysis we have completed and the threat modeling process. Let's pay attention to the most important elements of the network infrastructure for our resources. The most important are network policies. We can analyze them using Network Security Group service. First, let's go to the subnet section. The best practice is to assign network security groups at the subnet level. Try not to assign network security groups directly to network interfaces. This significantly simplifies the management of our infrastructure on a larger scale. In addition, we need to consider who can make the changes to our network policies. The most important thing is to control the permissions of our user groups and their user assignments at the Entra ID level. Also, we can check the access of a particular user or manage identity using Check Access button. We won't focus too much on inbound or outbound security policies. The way the security policies work is well described in the documentation. What is worth remembering is that policies should be added not only for inbound traffic, but also for outbound traffic. Let's create a simple network policy that will allow only our public IP to access our virtual machine via SSH port. What's important here is that your public IP address may change in time. Be aware of that. Our network policy should be temporary. Access should be removed as soon as we do what we need to do. And here's the result. Now let's add new network policy, this time outbound network policy. We should deny all outbound connections to the internet network. As for the subnet section, in most cases we will separate other logical subnets within our network. The configuration depends on the demand. However, remember that the communication method should be well reflected in the network policies. In our case, we've got only one subnet, and we don't need any additional logical separation. The next important section is diagnostic settings. Here we will add new diagnostic setting to monitor any changes regarding our network security group. We can store data in the log analytics workspace. I would suggest this solution because we want our environment to be auditable. And what do I mean by that? We need to answer an important question. If the environment is compromised, will I be able to prove that in a legal way? How can I prove that the data has not been manipulated? Therefore, we want to use the warm approach. Write once, read many. Log Analytics Workspace will be a good place to store data there continuously without the possibility of modifying it. However, it is important to remember about data retention that it can be modified in the Log Analytics Workspace. Another thing that we need to take into account is the way policies are added. For example, we can implement change control by using code in CI/CD pipeline. At the moment, however, this goes beyond the scope of our project. After we successfully added new diagnostic settings for NSG, we can see our results in the Log Analytics Workspace. Using KQL query on the Azure Diagnostic table, we can get the information about network policies processed. Although, be careful. Track your data ingestion on the Log Analytics Workspace. In some cases, it could cost a lot of money. Setting a daily cap may be a good idea. Let's now move on to the virtual network created for our infrastructure. Here, from the perspective of our project, we don't have many options to configure. The Azure Firewall option, due to our needs, will not be a cost-effective option. Taking into account the small scale of the project and low risk, purchasing an expensive DDoS protection plan is also not an option for us. The important thing at this point is that we need to control which resources are connected to our virtual network, and also we need to be aware of possible peerings between individual networks. The created peering option can be configured to allow connections only from one network to the second one, without allowing the second network to establish a network connection to the first network. It is not always necessary to create mutual peering, which is worth remembering to limit cybersecurity risk for connected networks. Let's go to the Bastion section. In our case, we want to limit costs as much as possible, so we will access the virtual machine directly from the internet using the appropriate configuration of inbound network security group rules without using the Bastion solution. So in our case, we will skip that section. The remaining topic that needs to be addressed is network monitoring. Standard corporate networks use tools to monitor inbound and outbound connections. Based on the information collected, they determine whether the traffic may be related to a cyber attack. Such tools also allow us to review packets in pickup format so that analysts reviewing a suspicious report can take a closer look at the network traffic that occurred. However, we are talking about thousands of dollars for a subscription to a given tool. Can we use something within Azure that will not burden our budget and at the same time allow us to monitor basic network traffic for our application? Depending on our needs, we can use two solutions for this purpose. First one is virtual network flow logs via Network Watcher. Here, however, it should be noted that the logs collected in the storage account grow very quickly. Additional features such as traffic analytics and dependency agent can be also very useful. Traffic analytics allow us to determine more precisely the type of traffic. In the case of having a SIEM solution, we could use these logs for a possible analysis of suspicious traffic. With a higher network traffic, you can expect at least a few gigabytes of data per day, where the additional cost is charged for the use of the Network Watcher itself. The whole thing can be very expensive. Additionally, we don't have default rules that allow us to analyze suspicious traffic. The solution itself can be very useful for traffic analysis, optimization, and detection of anomalies, but it will not be practical for our example. Although there is also another solution. If we care about network layer threat protection, we can choose the Defender for Servers P2 plan, which contains network layer threat detection, which currently costs $15 per instance. Also, it's worth mentioning here free open source IDS solutions such as Snort. Let's also remember that the proxy server like Nginx currently provides us with information about connections. Of course, detecting anomalies and suspicious IP addresses is not a trivial task. An example of an IP address blacklist could be Blacklist Alien Vault. We could use a SIEM solution to parse logs based on such a list of IP addresses. However, this would be significantly beyond our budget. Let's maybe back to the Azure portal, where we will take a look on the virtual network flow logs, the first solution for network monitoring that I have mentioned before. In the case of our project, we'll decide to use only Defender for Servers P1. Flow logs in this case will be only useful for debugging purposes. Nonetheless, let's take a look at the features that flow logs provides, because this feature could be very useful in many other projects. Let's create flow logs inside our virtual network. Here, recommended approach is to use virtual network flow log type, as network security group flow log type will be retired. Of course, we can enable traffic analytics feature. It will provide us valuable information about ingress or egress network traffic, as you can see here in our log analytics workspace. and also inside our traffic analytics section, where we can see some visualizations. For example, here we can see some network connections to the data center that occurred on Azure infrastructure. The second solution that can deliver us additional basic network protection is Defender for Servers P1. Considering the requirements of the project we mentioned at the beginning, this is the solution we will choose. It provides us many benefits. However, it should be taken into account that this is the P1 Defender version, which is based on the agent. The agent requires resources, which may result in additional server load. The P2 Defender for Servers version supports network threat detection in agentless mode. This should be taken into account when selecting a solution for a specific project. To make our example more practical, we can install Nginx reverse proxy on our virtual machine. Let's use a terminal to log into our server via SSH. Now we will follow documentation by adding necessary package repositories and installing Nginx. An additional step could be installing a Web Application Firewall module, WAF, on the Nginx server. One of the most popular solutions is Mod Security. But for now, we won't focus on that, because we won't be covering application layer security in this video. What we need to remember is to add inbound network policy that will allow anyone from the internet to access our Nginx service. Here we can access our Nginx server. Now let's turn on Defender for Servers P1. We can do this by going to the Environment Settings tab in Microsoft Defender for Cloud. Then we select the subscription that interests us. Now we'll choose the plan that interests us and enable it. Within a few minutes, the MDE extension should appear on our server. The next video will cover the configuration of MDE extension from Defender for Servers P1. Regarding network security, we should mainly focus on the enforcement level of network protection. The recommended configuration is to enable blocking mode, where we should first test the module's operation via audit mode. Also, what is worth mentioning is that ADR agent already analyzes suspicious traffic, even without the network protection module turned on, as we can see on the Microsoft Security portal. As you may notice, Nginx accepted connection from my public IP address. From a network perspective, these are most of the basic things that we can do in terms of configuration for this simple project. We could not afford to use all the security features available, but we managed to meet business requirements with limited funds. One additional thing that would be recommended is to gather access and error logs from Nginx and security-related information from the server to the storage account or log analytics workspace, which could be useful in case of any security incident. As you can see, there are many options, and depending on the business needs and requirements, we need to choose the solution that best suits the given environment. Creating materials like this takes a lot of time. If you appreciate the content I create, you can like it or subscribe to the channel. Thank you.